The previous lesson posed a couple of programming problems, and this lesson provides possible solutions for them. Let me say again that there are thousands of programs that will satisfy the requirements of the assignments. These are just my way of doing it. All right, here's the checkerboard. My solution was to first create a window that's 256 by 256 pixels, which I was able to divide evenly into 16 rectangles that are 64 by 64 pixels each. To handle the situation of 4 across and 4 down, I nested one loop inside another. The outer loop executes 4 times, 1 for each column of the checkerboard. Each time the outer loop executes once, the inner loop executes 4 times, 1 for each row in the checkerboard. That means that this entire block of code is executed once for each square on the checkerboard. Take a look at this if statement. This is where I did something you could call sneaky. I decided to let the background color show through for half the squares, which meant I only had to paint the other half. This if statement determined whether or not this particular square was one that had to be painted. Now, the value of I goes from 0 to 3, and the value of j goes from 0 to 3. So I determined that if the sum of two numbers was an even number, that was a square that needed to be painted. For example, if I is 2 and j is 1, the sum of those two numbers is 3. Which is an odd number, and that square does not need to be filled with black. So the next trick was to figure out whether this sum is odd or even. That's why I inserted the AND operator here. The AND operator looks at the bits and the numbers on each side of it and results in a value that is made of only the bits that are set to 1 that were set to 1 in the values of both numbers. Only odd numbers have the lowest order bit set, the 1 bit, so ANDing a number with 1 will result in 1 only if it's an odd number. If it is an even number, the result of the AND operation is 0, and the code to paint the square will be executed. If the number is odd, nothing else happens. The next job is to determine the values of x and y. Since each square is 64 pixels high and 64 pixels wide, it's simply a matter of multiplying the number of the square by 64 to find its position in the window. Once the location is known, a 64 by 64 rectangle is painted black. Now here's what happens when the program is compiled and run. And there it is. That's the 4x4 checkerboard. By just changing a few of the constants in the program, it could be modified to be any size and even made rectangular instead of square. The second half of the assignment was to create a window containing a shading of color from one side to the other. I did this by inventing my own color that had RGB values that provided me with plenty of room for change. The color fading appearance is achieved by filling a succession of rectangles, one beside the other, each one with a slightly different color. At the top of the paint method, the dimensions of each of the rectangles is set to the height of the entire window, but only 2 pixels wide. A color is defined using some RGB values that will be convenient to modify as we go. A loop is defined that will repeat itself until the value of x has reached the right side of the window. At the top of this loop, the set color method is called, and a rectangle is filled at the current position. The value of x is then adjusted by the width of the rectangle, getting ready to paint another one. The red, green, and blue values of the current color are extracted from the current color, so we can adjust the settings and create a new color just one shade lighter. Each of the three primary color value settings has one added to it, checking to make sure it doesn't exceed the maximum valid value of 255. Here at the bottom, a new color is created and stored in the color reference, which means that the new color replaces the current color. At this point, the loop starts over, draws a rectangle with a new color, and makes the same adjustments all over again. If we were fading to some other color, something other than white, these numbers would be adjusted toward the corresponding values of the other color and not allowed to go beyond it. But that's an exercise that I'll leave to you. Here's what it looks like. As you can see, the color changes from its very dark original setting across the window to white. The rectangles, being only 2 pixels wide, make the color transition appear very smooth. It's impossible to see any rectangular edges because the color change in the neighboring rectangle is so slight.